Testing, testing. Hello? Let's see. Might have audio now. Oh, okay, cool. Yeah, it's still warning me that my audio stream's current bitrate of 0 is lower than the recommended bitrate, but I think I'll just get started here. So this should, let's see. Yeah, all right. So unlike the last time I did kind of a live CTF stream, I have an automatic switcher configured. So when I alt-tab between IDA and my VM, it switches. So I won't be on IDA for 5 minutes while everyone's seeing the VM. Okay, so I don't really know anything about this challenge, but I'll run through what I've done for setup already. So I've modified, we receive these files, well, um, we receive a zip, and it's got the CPIO, kernel image, gnote.c, and a run script. So I've modified the run script for my own purposes to make it actually work on my local machine. I've also made this script to just quickly push my exploit in. That's all I've done. I haven't looked at the gnote.c at all, so that's probably where I'm going to start. We're only looking at a very, very small source file. So this challenge should, it's either going to be extremely subtle or extremely easy. That's the two options when you're looking at kernel source and it's this small. So we've got kind of some extra options that aren't implemented for some reason. It's kind of weird. Oh, you don't hear my music, correct, PVT? All right, so there's a continuous counter. We can put up to 8 notes. It only implements read and write. So we're gonna have proc gnote and then just read and write. No other, no ioctl, nothing fancy. It's got mutexes, so probably a race condition. Just kind of metagaming a little bit. Let's look at all the mutexes. Come on. There we go. All right, so for the entire write function, the mutex lock is held. So that means okay, it may not be a race condition because selected. Where does selected come from? Oh, okay. Yeah, so here I'll run through that a little bit more. So in the actual game, so in Tokyo Western CTF 2019, you would have had an SSH access to a server, and that would be on this QEMU VM. And so if we look at the files, there's this flag file, which we don't have any permissions to touch it. So like if I try to cat the flag, oh, well, apparently, it's not actually set up correct. I think I borked. You know what I did? I didn't run the CPIO as root when I rebuilt the when I rebuilt the VM, so I screwed all the permissions. So I have to fix that. But normally that flag would not be readable, and so we have to escalate to root privileges to read that flag. So I forgot to run the CPIO commands as root when I did this. So I can go into my root folder. And then I want to sudo. So CPIO will preserve permissions if it's run as root. So I just have to do that. Oh, that's really bad. What just happened? Huh. Oh, right. I need to do back. There we go. Okay, so now if I do like, now you see it's owned by root, whereas previously it was actually owned by the default user. So that was my mistake. And that means that I also need to edit my script here and do that, and probably that. Yeah, that'll do. So now when I do the run.sh, I should probably get Discord up on my screen. Yeah, now it's owned by root. So now we can't actually touch the flag. So the goal is to get escalated permissions and get the flag on this particular challenge. The goal in general in CTF, which is capture the flag, is to get the flag. Um, so you might have some service that's implemented or like a website where you have to get the flag from something that you don't have permission to access. There's various categories. All right, so let me do some window monitor stuff. Where is, just checking Discords real quick. Okay. All right, so back to the source here. So there's this selected, which is if selected is -1, then we unlock the mutex in return. And we set it to -1 after we copy from user. So case 5 is to select an index. So we have to, so the command is, well, this is wrong to begin with. It's directly dereferencing user memory. This should be copy from user into a local buffer. So like if no, wait, no, that's passed in by the kernel. Never mind. I'm dumb. Er, actually, yeah, I think if I do like uh I'm gonna need CNCL for that, I think. Yeah. And then do like write FD. Let's do like uh let's do something in high memory. Right? Tell it we want to write 1 byte from some nonsense address. And then so now when we run exploit.elf, I guess maybe this doesn't behave the way that I think. Maybe I'm just being a dumbass. It's entirely possible. I should probably just gonna update my script, like put it all into one. I really should just be catting that. Oh, pushed. Oh, needs to be bash. Okay, so that just doesn't behave the way that I thought. I don't know. I might be being real dumb. There might be some filtering that I'm not familiar with, but it should be, like, whenever you see something touching an underbar user pointer directly, that jumps out to me as wrong. But this is, actually, I need to check the uname. Don't mix Vim and Emacs muscle memory, guys. Yeah, so this is Linux kernel 4.19, so there's a lot of mitigations that I won't be immediately familiar with. Most of the work that I've done was on kernel like 3.18. Um, so there's some new stuff that's been added, um, which is why I just want to verify that this isn't. Yeah, see, okay, that's what I expected it to do. Okay, so what just happened is um, we kernel panicked the system. Um, so if you see, it says unable to handle kernel paging request at deadbeef. So that's because when I used this write syscall, I told it to, I gave this buffer is this second parameter, and yeah, so that's very wrong. I don't know if that's going to be part of it. I mean, you could theoretically, like if you had an info leak, you could do something maybe. Um, yeah, so it also gets, it never does copy from user, does it? No, it doesn't. Oh, this is going to be subtle. I mean, this is like almost a 500-point challenge. I think it finished at like 460 something. So hopefully I'll at least have the bug within. I'm going to be streaming for about 4 hours. The I've got some stuff going on at 9 p.m. Eastern. Um, okay, so that's one thing that's wrong. I'll start up some notes. I don't usually do this, but since I'm probably going to be working on this challenge, kind of spread out whenever I have time to stream it, I will start up some notes. So if you write with an invalid address, dereference without checking user. Um, okay, so there's it's got these three like not implemented things, which is weird. I guess that's just stylization or something. Oh, let's check the structure. Unsigned long size. Okay. So these are all unsigned longs. If there's any sign comparison stuff. How does Oh, I'm like vaguely remembering there might be something weird with this. Oh, okay, so this is IDA. I'm gonna pretty kind of assume that people are familiar with the tools because this isn't really an intro stream. Um, but let's look at gnote right. Where's that? That's right. Where's this comparison? I'm in gnote right. Is IDA just booping itself? Yeah, it is. IDA doesn't like this. Cool. That's good news. So Hexray's output is incorrect. If you look, this comparison here is just completely not in the Hexray's output, and neither is um yeah, it looks like Hexrays just doesn't like this at all for some reason. I tried in Ghidra, um, but I probably don't need it. I do have source. Um, come on. Okay. Okay, yeah, see this like bit up here too. Um, it's the whatever the auto analysis from IDA is just really breaking. Yeah, see how it like decided that these are all subs? I think I can fix this by undefining a bunch of stuff and then telling it, so what's the end address? C1 or C0? So then you can edit function, and then end address, yes. And then tell that this is all code. And then, well, that didn't seem to work. Well, this is annoying, but I imagine this is part of what they're kind of intending to do. But at least we get kind of somewhat a more sane output now. Ow, come on. My spacebar on this keyboard is busted. So we get slightly more sane output. This is still broken. Whatever's going on here. Yeah, it doesn't like this indirect thunk uh like switch. If anyone happens to know how to fix that, let me know. This isn't something I've encountered in IDA before. I will actually try Ghidra. So that's gonna require me to modify my OBS settings, but I'll fire up Ghidra real quick. So just bear with me for a moment. File, open project, stuff. Sure. File, or let's drop in. Where's gnote.ko? There it is. Drop that in. I'm just not showing all of this because I don't want OBS running wild, so I will add gnote.ko has not been analyzed. All right, so while that analysis is updating, I will fiddle with my OBS settings. Let's add a scene. Ghidra. Oh, OBS like automatically goes to that scene. Cool. Window capture. Okay. Where the heck is Ghidra? There it is. And then fix that. Tools, advanced scene switcher, window title. Where's Ghidra? Browser, scene Ghidra, add. Okay, so now when I switch back and when I switch back and forth between my virtual machine, let's see, are you gonna switch? Oh, there's actually a decent amount of delay still, even though I'm on ultra low latency settings. There's about probably 30 seconds of delay. Yeah, okay, it's auto switching. All right, so let's see if, yeah, Ghidra doesn't like it either, actually. Holy cow. Flow override, call return, call terminator. Holy cow. Well, that's fun. So I guess this is probably where some of the difficulty of this challenge comes from, is whatever they're doing with, like, whatever the switch statement um is doing. I think there might actually be um like, at least at the very least Ghidra will kind of allow me to okay, so that was wrong. At the very least, Ghidra will kind of allow me to see some of what I wanted to see. Um, yeah, so that's that function. Let's go to write. Is it this? Is it this stub? Yeah, here we go. Okay. So this JA. JA is J JA is an unsigned jump if above. Okay, so I wasn't sure. There's a thing that can happen sometimes, which I've run into. It might just be because I work with a lot of janky versions of GCC sometimes, where it will assume that a decimal constant is signed, like a integer constant is signed, and convert that to a signed comparison. But I don't think that doesn't appear to be what has happened here. Um, so I'm not really seeing anything right now. Um, we can go to options and do auto comments since, yeah, jump if above. So that's the unsigned version. Oh, wait, hang on. Hang on. This is a talk tau. There's talk taus everywhere in this. Time of check, time of use. It is a race condition. I'm just being a dumb. So they're repeatedly dereferencing user memory. So for the same reason as I said before, where you should be using the user primitives and copying in the buffer. So like let's say we've got right like this check right here, right? Oh wait, hang on. No, they're copying it in. Never mind. Yeah, they're copying it in both of those places. Let's check. Index, unsigned int, count, unsigned long. Yeah, I'm not really seeing anything. All right, so they do copy in the size. All right, so let's see every place that they touch the buff. So that's it. Do they ever use count? Okay. So if we can create a new note that's empty. So that's case one. Right, so we'll kmalloc a new pointer, and we can select a note. It's an interesting challenge so far. Well, let's just try some things. Let's take a closer look at the disassembly first. Where's that? I don't see why this is here. Oh, to get the size, right. So this guy, we have struct notes, so that's going to be in the data segment. Well, we have two functions available. And so this is going to be or I don't know how I want to do these functions. So we can just start with like unsigned long size and go with uh, let's make the file descriptor a global, although we're probably gonna have to change that if it's a race condition. I'll burn that bridge when I come to it. So add note is gonna do right. So the command is unsigned int, unsigned int. So the note command is case 1. Come on, my spacebar on this thing is going to drive me crazy. I really need to get that fixed. This is going to be size, and then right FD CD. So then we should be able to, let's do add note to make it do 8. Oh, George Martin's. So if you're looking for books, I'd say the best way to get into kernel exploitation is to start with just learning the Linux kernel. So you're going to want to grab the Linux driver developers manual, LDD v3. It's a little bit out of date, but it's a really good starting point. And then uh, from there, I don't know a lot of like traditional resources. Read CVEs, look at existing end-day exploits, CTF challenges. I learned by doing, so really that's the best advice that I can give. Um, so if we run this exploit now, okay, so that seems to have worked. Do I have demessage permissions? No. I should probably fix that. I'm gonna do this. So let's let's go into the root. And then do, what's the command to, and then I want to do, and then what's the command to add the suid bit? It's like chmod 4755. Okay. 4755. Oops. So this will give me a root shell in the VM for testing purposes. Right, so now when I run, I should just be able to do, oh, that didn't work. Why is that not suid? Oh, no, that's wrong. I'm just gonna Google make suid root binary. I mean, it has the, it, it should have that bit. In which numbers attempts to remember how to do literally any sysadmin things. Hello. If anyone has any idea why me trying to make a suid sh binary is going so poorly, or if there's a better way that I can give myself demessage access on this VM, let me know. Because this is kind of turning into a whole waste of time. Right, this should just work. Like if I do and then shown root sh and then sudo chmod u plus s sh. Yeah, that doesn't, I guess that does. You expected me to have an accent? Yeah, I don't know either. Well, I'm gonna just give up on this. I don't need demessage output. We can work without it. I will probably do this off stream because I don't wanna waste a ton of time. All right, so we can definitely add notes. Just gonna do kmalloc. There's no k-free. There's very, very few primitives in this. There's probably a way to turn this copy to user into a there's probably a way to turn this copy to user into a infoleak primitive, right? I wonder if there could be something, the KVM Linux bug. I haven't really been following Linux bugs for a while. So it's entirely possible that the reason that because they quite deliberately compiled this to make IDA behave weirdly, or like this, they could have chosen to make this jump table um kind of a different format. So I'm wondering if GCC did something weird, and so there's some bug like that's in the assembly but not in the source. If you get this mutex lock, where's the mutex unlock? Mutex unlock is here. Okay, so that all jumps back there, and that's where we unlock. So like that looks roughly correct where the lock and unlock is there. So we're adding to the count inside the lock, which is correct. Wait. Wait. Is that in the source? Yeah, okay, so this is kind of weird. It'll write the size, right? It writes the size to the notes buffer, and then it checks. So it'll only kmalloc if the size is in bounds, but otherwise it'll still write the size. And so that would leave the contents pointer uninitiated or uninitialized. So but I don't see how that's useful yet. Right, so does it also only updates the count if so it doesn't update the count, but it does set the size. If you give it an invalid size. So I should make a select note function. I should just copy this. There's no reason for me to be manually typing all this out. let's assume we can update this. Well, I'll just do 08x for now, just to keep things nice and even in the output. So then if we do select note, it's going to be 0. Count greater than. Greater than index. Selected equals index. And we unlock. Okay. And then I need to grab a snippet. Where is the hexdump C snippet from gist that I always use? Here we go. This is the most useful snippet of all time. I'm just going to put that in like so. And then do something really horrible. Yes, you can do that. Oh. Aw, wait. Oh, I need quotes. At least I'm pretty sure you can do this. Yeah, you can. Real dumb. Don't do that. Okay. And then that should let us then we can do like car output out. So that should be 8 characters. Read. So this should just give us zeros. Like we shouldn't expect to see anything interesting from this. Except that we did. Oh. Oh, that's dumb. I'm really dumb. This is just kmalloc. It never initializes this buffer. So there's like a free info leak if you want it. Oh, that's horrible. Because if you want to leak something specific, then I guess you need to like spray the, well, you can't really spray the kernel. You just have to pick a bin size that you like. Yeah. Okay. I mean, sure, that's an info leak. But I don't see where that's getting us, but that's some progress. So we can add int read note. All right, so we're gonna do car star. Let's make this a car star. Car star out equals malloc. Size set out. I don't know why I expected that to just give me zeros. I think so. The 0th index, if I remember the kernel structures correctly, I don't think I have kernel source here. If we look at kmalloc slab.h, That's not what I'm looking for. Just pull up the slab allocator structures real quick. Give me the slab. This has been so long since I've... Here we go. Yeah, I'm pretty sure the first... index should be the linked list. But it's been a really long time since I did any kernel heap stuff. And I'm actually not even 100% remembering correctly. That's one of the reasons I chose this challenge, is I needed to brush back up on my kernel. It's been a couple of years since I really did anything seriously in terms of kernel exploitation. All right. So then we're gonna do read the out size. And then it's gonna be size and res, turn out. Kernel exploitation without a debugger or panic print? Yeah. Yeah, on a weird proprietary kernel too. I mean specifically any Linux stuff. It's been a minute since I've done any Linux exploitation. All right, so then I should just be able to... Come on. Okay. And that is behaving as expected. So let's change this up to 16, or let's do like just to see. I'm expecting to see some pointers here since it's uninitialized heap data. Yeah, okay. So that's a pointer. Well, it's probably a pointer. Yeah, that's a pointer. That's a pointer. We got 3 pointers. It's not really consistent, obviously. It's probably KSLR going on and stuff. We don't really care what that is right now, because we need other primitives before we start caring what that is. So yeah, I'm almost an hour in. Let's see. Yeah, 2 minutes to the hour, and I'm not really seeing any sort of primitives we could use to get corruption. So there might be something weird going on with the compilation. So let's take a look at IDA again. All right, so we've got this is gonna be, and then we don't care about any of those. That seems wrong, right? JNB? Or no, because that's jump not below. That's gonna be, yeah, that's less than or equal to. If count greater than index, so yeah, that's gonna break if, yeah, break if greater than or equal to. So that's correct. And then we're gonna move racks into the selected. So again, that looks correct. And then read is gonna disassemble much more nicely. So, what are you doing? I guess that's just how Ida decided to disassemble the CS thing? Sure. Um, wait, V4, okay, so that's notes 2 times selected, okay. Again, this is all inside of the mutex, so like anything that would look potentially interesting in this just doesn't. So the size, unsigned less than or equal to how many bytes we offered. And we truncate. So if we look at selecting, actually, I think if I like, I'm gonna edit this and like truncate the crap out of this function and say, I don't care about you for now. We'll make a function here. Cool, okay, so we can at least like slightly disassemble that now. So as long as we have less than 7 unsigned. This seems weird. This like storing it off to the note buffer prior to it's the size of the storage. It's an int 64. Will that sign extend? I'm not sure whether this store will this access, right? Like if this is FFFF, I guess it's unsigned, so it won't. Um, hmm. Man, this is a tricky one. It doesn't check the K-Malik failure case, which like whatever. Then it unlocks. I really don't see anything. All right, well let's fix this that we did. And then, oops. we want to extend this down to C1, right? Really? Can you set it to C0? Really? That's weird. I guess we need to undefine everything, maybe. So that should all be undefined. I might have to recreate my IDB. Sometimes IDA just gets in a mood, and I'm not sure what's preventing that from happening. Let's try, oh, maybe we just need to define everything as code. Maybe. And then edit function. There we go. Well, well, now we should be able to do it. Yeah, there we go. Okay, we're back to the nice busted state that IDA was in. So this is all inside of the mutex. So is there anything weird? Can we do anything weird with the lock? Not sure. Yeah, it's this switch it doesn't recognize. Compare to 5. That's correct. Is that correct? 0, 1, 2, 3, 4, 5. Yeah, that's correct. Hmm. Yeah, I'm really not sure. I'm sure there's something. I'm just not seeing it. Um. It's got to be something with this jump table. Oh. Oh. Wait, GCC does this? The fuck? It is GCC. Okay, well, I appear to have found the bug. Or at least another bug. Um, so this is freaking fantastic, actually. So if you look at the source, I don't know how I didn't spot that for so long. I just had to stare at it for a few minutes, I guess. If you look at the source, so we have this where is it? This switch star buff. It looks fine, right? We're just gonna dereference it once, whatever, right? But if we look at the assembly that GCC actually emitted, right? We have it's going to compare it by dereferencing, and then it's going to dereference it again. And so what that's going to cause is if we have some, user, if we have two threads where one is repeatedly attempting to do a command, and the other one is repeatedly swapping the command value back and forth between, say, like 1 and -1, then when it goes into here, uh, where it's gonna dereference it again here, we can theoretically we can pass the comparison where when it checks it here, it's less than 5, but then when we hit this, when it dereferences it again, it's not. So let's implement that. So that means we're gonna need to get pthreads involved, which be nice if I could remember how to use pthreads without having to Google it, but who has time for that? So let's get all this and just like put it in a comment for later. So it is a race condition. It's just a race condition that's not in the source. That is something. That was the first thing that I noticed, and that is actually the source of the bug. Give me 1 sec. I gotta start up a different album. I have desktop audio muted, but I am listening to music. Let's put on a different. Let's see, Blue Tech. Oh, he's got a lot of new stuff out. Is this a full album? It is. Hello. All right. So for starters, we're gonna need to create some thread functions. So let's do void spammy void start a. It's pthread prototype. And we're gonna want like a signed int cmd to bad. So we're gonna do while not exit. Let's just put this in here now. While not done, then we're gonna go with bad 0 equals. Let's put it on 3, right? And then bad 0 equals. All right, so this should crash in a real glorious way when it's done. So we're gonna go with pthread pthread create act t null spammy null. So that'll start that going, and then do this and do so we're gonna do write fd bad Bad. So this should crash pretty quickly, I believe, if it doesn't fail to compile. Incompatible pointer type, really? Expected void star. Oh, needs to be void star. And then undefined function. Oh, I need to add. No, stop. Well, my terminal's hosed. So we have to add tach LP thread. Please work. I think I just messed up my GCC command. Is it just tach static tach pthread? Like that? That should do it then. So this should kernel panic essentially immediately. Did I mess it up? I think there's like a maybe I need to like, I think there's a QEMU option in here that's causing something to get eaten. No graphic, SMP. Okay, so it has SMEP. It does have SMP, which should have let me know immediately. I'm not sure. Like this theoretically should work. Let's add OO, just in case something weird is happening there. I wish I had dmessage output. I think I need dmessage output now so that I can see if anything is happening. Linux boot dmessage permissions. That's probably not it. That's all Red Hat results. So I'm assuming, am I just making a mistake here? This should alternate between printing This should alternate between printing like a success and fail. Oops. Oh, it always returns 8 no matter what. Oops. Clearly doing something wrong. It's probably something dumb that I'm overlooking. Oh, you know what? I probably need inline assembly. This is probably too slow. It probably needs to be like a 1 instruction hot loop. Whoa. Oh, right. What did I call that? Okay. Oh, well, so this test is probably going to make me lose this most of the time. So let's get rid of that to start with. Oop. I don't know what that was. I don't want to write inline assembly. Oh, let's just do it. So it's gonna be like oh, I need like the back end, right? So that's I don't know what I'm doing. Let me think this through. Well, that's wrong for one. I'm doing this really stupid. I hate writing assembly. X64 cell. I wish there was a way to tell this thing that is there a way to use Intel syntax? Is there a way to use Intel syntax in GCC inline assembly? There has to be. Ah, MASM Intel. Okay, that'll work. And like so. All right, so that's gonna be like I honestly don't remember my x86 assembly syntax at all. Which makes me feel real dumb. Yeah, that's correct. Swapping back and forth mentally between Intel and AT&T syntaxes is just really stupid. Let's do like I think that's how that works. It's like, wait, let me see, X GCC inline assembly Intel arguments. Okay, no, it still uses percent. So we want like a hot loop, probably with like an exchange. I think that's faster. And then so at the end we're gonna do like don't need those. It's gonna be at least that part I remember fairly well. Is that right? It could be right. Something is wonky here. I can get rid of this net stuff. A little bit easier to see. Well, that compilation failed. I don't need this comma. Register type mismatch for exchange. Oh, I used the stupid Intel AT&T syntax. There we go. This should crash. Please crash. Well, that's not what I wanted. Oh, because I gave it null. That's a null deref. There we go. Hello. Okay. Yep. Look at dereferencing racks, dereferencing dead beef. All right, so let's. Okay, there's no smap, and it's dereferencing. Wait, did it just dereference dead beef directly? What was the assembly? I I think if I do like um and then do uh I gotta do let's just make this a structure or just put this on the stack because we're lazy. Sure. So this is gonna become oh, that's bad. Well, back to uint 64 I go. No, did I not? Oh, I guess I didn't include stdint somehow. Unsupported instruction mauve? I'm sorry? I'm sorry? Oh, there we go. Bad rip value. Where's my rip? Show me my rip. Where is it in all of this crap? I don't. I. Uh. Well, that didn't really. Oh, I guess it kind of maybe did. All right, that's a user space address. I think I just messed up my dereferences a little bit. Right. I wanted maybe just that. I should just, you know what I should just do? I should just do, um, like, no, that's not what I said to do. Okay. Uh, read write. So I'll just put this on its own page, make things a lot more obvious because noodling around is just a waste of time. So we're gonna want um so we want the address of map to become this offset. Right, so the only other thing I'm not 100% sure of is this like DS offs whatever, like how this actually behaves. But I can just like figure that out by fiddling with it, and figuring out the actual offset that I need to add to the address that I want it to dereference to get the program counter address. Um, let's see, time check, doing fine. So that should, let's also do memset map for one, set that whole page just in case it happens to be within the page. And I think that might work. I probably am missing something. Yeah, I'm fine. Bad rip value. So Rax is 8,000. Is it gonna tell me the rip? I mean, it says rip is like here. So I'm running into, it's not actually jumping there, is it? It's gonna be, yeah, it's gonna be at like this address right here. Or it's gonna be, wait, rip. Gnote right plus OX20. It should be right here. I'm not sure. I mean it's using my Rax value. Um, come on. Oops. So how does DS relative addressing work? All segment registers except FS and GS are defined to have no effect. and behave as if they mapped the entire user. Okay, so that's just the compiler being weird. So that means it's gonna do, right? Yeah, it's literally just gonna add 220 to it. Um, so if I do like, I really want to get program counter. Like I really want to get an obvious bad program counter. So if we set this to OXO, I probably need an info leak. Um, I'm assuming this is where the, like this address is. Well, let's turn off KASLR for now, just to save some time. Yeah, let's get rid of you. And maybe, and then we'll just panic it to get some addresses. Yeah, okay. Uh, yeah, DS is 0, so that's fine. What am I doing? I need to think this through. So it has KSLR, so I need to leak the kernel slide and then write a ROP chain. Well, I've been live for about 2 hours, so I'm gonna take a short break. I'll be back in about 5 minutes. I'm just gonna stretch my legs and drink some water. So back shortly. Thanks for watching, everybody. Okay. Hello, I am back now. Um, so we should have I need to set up probably for some debugging and download the Linux source and take a look at how I want to leak the kernel slide. I'll set up debugging when I need it. I actually generally work without a debugger a lot of the time when I'm doing kernel stuff. It's really unconventional, but the same thing Kiwi was referring to uh, is why I would tend not to uh, use a debugger. So for starters, if I recall, let's just run this real quick. I need to grab the Linux source. So that's going to be 41965. So let's just grab Linux 419, kernel archives. I don't think 41987 would make that much of a difference. Just gonna maybe have some slight differences, but I'm mostly just looking at. I read recently about a technique which I've not used. So a couple of these commands are going to take a few moments. So what we're going to need to do, so we have this info leak, right, where we can leak an uninitialized uh, heap object from any size, um, and there's a number of heap objects that are going to have function pointers. So you can use like some of the wait queue stuff, some stuff from drivers. But recently I read about using timer FD, which apparently I'm gonna look up the source for because I've never actually looked into it, but um, it may be useful for getting that info leak that we need. Where's my window? There it is. Just gotta keep my preview up. Okay, so that's done. Let's run some G tags in here. This is what's gonna take a minute. Let me quickly find where the timer FD source is. It's going to be fs timerfd.c. Okay. Oh, that's bad. Um, yeah, that's really bad. Well, I'm out of space. Um, how much space do I? Yeah, I'm completely out of space. Yeah, I don't know where all of that's coming from. So for a moment, let me uh make sure that this isn't gonna auto switch. Okay, it's not. Give me a moment to free up some space. Uh, okay, well that freed up 5 gigs. Um, maybe I have something big in my home directory? Mm, oh, I have 3.7 gigs available, so that might be enough. Switch back here. gonna switch back. Yes. Okay. I really need to make a bigger VM at some point. I don't know where all of my space is. It's a 20 gig VM. So I have, okay, yeah, I should have enough space to run gtags. And then in the meantime, we're gonna go to the Linux source fs timer fd. No, there we go. All right, so there's a syscall. So I think the CTX structure might be the idea. I know there's a function pointer in here somewhere. But I don't really know anything about it. So we can look through. Let's go for, maybe I'm in the wrong place. Maybe, you know what? I think it's just this HR timer thing. Um, I wish I could remember where that article was, but I don't want to Google around too much while I'm doing this because it's been solved and I don't want to stumble across stuff that's potentially related to this challenge. Well, I'll take a look and see if I can find anything. Oh, literally the first hit is the RPISec write-up for this challenge. So, well, that's some info that I would prefer that I hadn't found. Um, but that's fine. So I know that I'm at least on the right track. Somewhere in all of this is going to be a function pointer. Yeah, see, okay, here we go. K-free RCU. So there is a K-free, and that's from CTX, which is passed in setup, which is called from here. So, oh, KZ alec. Okay. So it's got to be this CTX struct. Is one of these a function pointer? No, don't. There we go. It's probably this thing here. I mean, we could just try it. I would like to know exactly where this function pointer is, though. How big is this? Oh, here we go. Here's the function pointer. Okay. So this is gonna when we start our timer with the time, or when we like initialize the timer with the HR timer, we're gonna be looking for this function pointer in the struct. So that's gonna be, man, it's just structs all the way down. There's like I know there's some scripts and stuff that will show you these structure sizes. Um, it's probably the OX 100, maybe? Depends on how big. Depends on how big some of these are. It's like an RB node. Yeah, that's like 8, 16, 4. Man, these just keep getting bigger. Oh, you know what I can do? I can do this. I'm being stupid. Um, uh, no, 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 no. Really? Cool. Let's temporarily hide that. Oh, this doesn't have any symbols. Of course it doesn't. I mean, I wish I still had. I wrote a script a while back to do, um, I wrote a script a while back to do, like parse the KL sims and put symbols into your extracted kernel image. But I don't feel like recreating that right now. Um, so I need to change this to IDA, 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 IDA. There it is. There we go. So now it'll switch between these two IDAs. Let's just go with, I'll just leave just the one open for now. I don't think I'm going to need the knote one for a little while here. All right, so this is going to take a little while to auto-analyze. So in the meantime, can think about what we're going to need for this exploits. So this is like a POC. So let's, come on, spacebar. Let's just store that off. All right, so for starters, we're still gonna need this stuff at the very least. So we want to do info leak first. So there's got to be some step of doing I really wish that I could fix that. There we go. So, whoops. All right, so we're gonna have like What is the clock ID? I don't think it matters. Clock, real time, flags, 0, we don't care. And then probably close. Well, let's like spray these. Let's do like, so this should create a ton of stuff on the heap. And then we can repeat it and just close all of these, I think. And that should like fill that bin with those structures. And then so there's the one thing that I'm not sure about is this is on the release, right? Is this K-free RCU? So how does that work? Let me Google it. Not really encountered that particular function. K-freeze the specified memory after an RCU grace period elapses. So just sleep? I mean, we can try it. There's no reason not to try it. And then we probably want to do, so let's do read note. No idea what size it is. So then if we look at this crap, it's going to be in the HR timers, it's right at the beginning. K time T is 8. Yeah. And then timer queue is an RB node. So that's going to be 1, 2, 3 size of, so 3, 4, that's 16, or that's 32 bytes, 40 bytes. Okay. So then no. I'm going to convert that to hex. And then okay, so we need to determine what size we want to read. Let's check on IDA. Auto analysis is done. Okay, so in this in timerfd.c, do we have any strings? Yes. There we go. This should have some xrefs. Okay, so that function is timerfd show. So somewhere, so like 3 functions above it should be a reference to, right, it should be, so this is timerfd show. This is it's this loop. What about, where is it? Oh, that's not what I meant to do. Oh, hang on. We can go for strings. Maybe this. Yeah, okay. There should only be one xref to this function, to this. So this guy here, turn this into a function. It's the timerfd function. There's a bunch of nonsense in here, and we don't know where kzalloc is. But we can look for like a function call with this guy. Yeah, so this is a k. That that seems not what I was looking for. Why is that 0? Right, that should be GFP kernel, if I recall correctly. Oh, size of star CTX. I wish there wasn't so many comparisons. I wonder if there's an easier place to find this to find the actual kzalloc so we know exactly where it is. Oh, well, one of these is the kzalloc. I mean, that looks like an alligator. Right? Yeah, so this is like the init wait queue head right here. So, and then where's the null check? Yeah, there's the null check. So this is definitely kzalloc. Oops. Why does it? Oh, because it's like doing a fucking weird dereference thing, which is annoying. Well, let's just try some. Or actually, what's the there's like a proc entry for kernel reporting, right? Like proc meminfo. Um, yeah, like proc slab info. Um, yeah, and then so what I should be able to do on my host machine, If I go to like oh I think that caused that to open something that I didn't really want it to. Yeah. Goodness. Awesome. One moment. That shouldn't even be mounted on this VM at the moment. So let me try to fix that. Uh, it doesn't appear to be shared. That's not correct. Huh. Well, I'll just be more careful with my commands, I guess. All right, let's just copy all the includes because I'm lazy. No, that's not what I said to copy. There we go. And then we can do this. And like, let's make this a lot. And then and then oh, do I not have KDiv3 installed? I don't. Well, that's a lot of things that it wants me to install. I probably shouldn't have installed this. I'm gonna run out of space again. Oh yeah. How much space did it say it was gonna take up? Oh, just like it's 500 megs. It's fine. I'll survive. I don't know why this is installing so much when I just asked it to install a diffing program that I like to use. So what I'm doing is I'm figuring out which slab it's in by using the slab info and just making a bunch of them and seeing which one changed by a bunch. And this is the laziest possible way to do this. What all is it installing? It must be installing like an entire graphical front end. Yeah, it's installing like GPU drivers and stuff and lib Blu-ray. What? Please? Okay. Okay. So, yeah, see this? See this big change? And this big change? Let's see. I don't know if these are given in hex. I mean, if they are, this is pretty much exactly what I would expect to see in 256. That sounds reasonable. So let's try that. Oops. Let's run it. Void value not ignored as it should be. Oh. And then this is gonna be whatever, I'm being lazy. That, oh, I didn't select it first, did I? No, I forgot some stuff. Add note, select note. Well, let's annul. Let's only free like half of them, just to make sure that that bin is really, really sufficiently churned. There's nothing in that. Maybe there's something else that I need to do with the timer to get it to, like, maybe I need to start it, possibly. Looking at this. Oh, you guys can't see that source. Yeah, this doesn't actually do anything. Maybe I actually need to like start the timer. Set time. Sure. Let's try that. Struct I timer spec. I Dude, this is massively overcomplicated. Where's the I timer spec? Here we go. Well, that's not helpful. Oh, they're both just time specs. So that's going to be like, right, so like 0. I have no idea if this is the right syntax. Probably isn't. But it could be. You never know. Set time starts or disarms. The new value, initial expiration interval. Timer spec used for this contains two fields. Interval and value. IT value, either field to non-zero arms the timer. Okay, so that's going to be like, right, or no, we want to just, whatever. That's TWCTF. Yeah. So that should arm the timer. If I then do, what's this syscall? Oh, I'm just typing from there. Spray FDs I, and then do I care about flags? No. And then that's going to be like ampersand spec and then null because I don't care about the old value. I don't even know if I need to be spraying. I'm going to probably disable the spray. Oh. Initializer, but incomplete type. Did I miss type? I did. There we go. That didn't do anything different. Let's try it without spraying. I've never used this technique before, so I'm not 100% sure. But I kind of generally know how these things should work. Really, I just don't want to spend an hour reading the iTimer source code, or like the timer FD source code, which I could do. Normally I would, but since I'm trying to solve this in under 4 hours, I'm hoping to get lucky. Which I might get lucky. I don't think I'm going to solve it in under 4 hours still, but I want to get as much progress done as I can. Oh, what the hell? So that just works? Cool. If I don't close this, then, I mean, that is definitely a kernel text pointer right there. See that 8.1? Yeah, that is 100% a kernel text pointer. And then I should get, if I put the free back in, yep, okay, so I didn't need to spray at all. I was just being a dumb. All right, so let's turn ASLR back on. And we should see this pointer change. Why do I have a spurious input in my files somewhere? I don't. Yeah, see how that's now, see the 2FO, A2FO? So it's the same pointer, so that's reliable. But with ASLR turned back on, we're getting, did I turn it back on before I ran there? I turn it back off. I mean, I'm assuming that I'm getting exactly what I think I am. So like, I saved though. This is, maybe I never turned off. I guess I never successfully turned off KASLR. Oh, I need no KASLR. I have a spurious new line in here somewhere? Like I don't understand why this isn't behaving the way that I feel like it should. This QMU command. There we go. That's correct. So if we go to like, I don't know what the actual base is. Let's try this. Oh, it's 8.1. Okay, so yeah, there's a function. Hello. So we have a kernel pointer leak, and I probably just screwed up my OBS layout. Nope, we're fine. So if I copy this line back in, is it still going to be complaining at me? I don't know what it's not passing to QMU necessarily. Where's my music? Music library. Let's listen to some Taylor Swift. Well, I get to listen to Taylor Swift. If you want to listen to Taylor Swift also, you're welcome to. But I don't want to get my VOD muted. All right, well, I must have just had a weird input in there somewhere. Okay, so we're leaking a K pointer successfully. So that means if I want to go to like, so I need to write a ROP chain, I guess. Because I can get program counter now. So let's start let's get Rop Gadget going because that's gonna also take a while. And see if I can find something really fun to call with my program counter. Or I'll just wait for Rop Gadget. Or search text. Or actually, I can just go to. So that gets me the kernel text. I don't know where the actual library is loaded. Oh, search text. This is gonna produce about 1 billion results, but that's fine. Oh, that's done. Okay, so we don't have to worry about. I guess they made that faster, or my VM is just much faster than I'm used to. So let's just hide this real quick. Pack database. Open up the gnote. Unhide it. I really should have set this up with 2 IDAs, but I'm lazy now. Okay, so RBX is gonna point at where we are. So we want to do like we want a stack pivot. So what do we have for controlled registers? I mean, RBX points at our data when we hit this. So we want like, EXCG. Oh, I literally wrote it right here. It starts with an X. Exchange RSP, ESP. Oh, I want. Is it like Control U, Control S? Yeah, there it is. Okay. XCHG. No. XCHG. XCHG. ESP, comma, dot, dot, dot. Rets. So we don't have any of those, so that's fun. So we have RBX. So would this work? It's gonna dereference racks. That's bad. Oh, this will work just fine right here. So let's grab this gadget. Right, so then all of these are going to need to be subtracted by, what's the base? Damn it, I literally just had it. It's like 8-1 followed by a bunch of zeros. So, we're going to remove everything before this. think. All right, I need to open up another instance of IDA. In the meantime, make sure that it's going to be image.i64. I have no idea what this is going to do to my auto switcher. We can fix this. Add scene, IDA 2, add window capture, or window capture, and then create new. Sure, that seems correct. And then tools, advanced scene switcher, title. We want to remove the one for image, add one for image, cut to IDA 2, add. All right, so now when I switch back and forth between my two IDAs, is it not gonna switch? I I don't I don't know that it matters. Whatever. Yeah, okay, so this is the base of this kernel. This is the base of the kernel text segment. Is this? So all right. So I need to get the actual kernel base, which means did I have no idea if my switching is working correctly now, actually. This is kind of a problem. I think I just messed it up. Let's try to fix it. This is kind of a waste of time, unfortunately. Like I don't know why it wouldn't be. I guess maybe it is. I think my delay is still pretty darn high. All right, so what I need to do is I need to leak this address again. Let's do that. Do I have no KSLR on? Yeah. And then we're gonna go to this address. And that is at 335A2FO. Well, let's just subtract the base from this. I really need some caffeine, but it's late and I don't want to caffeinate. My performance may go down accordingly as the night drags on. This will get us the offset to get the kernel base. That's this. All right, so now the kernel base can be leaked. Is there a ROP gadget offset Specify an offset for gadget addresses? I I mean, maybe. I just wish I could subtract from all the gadgets without having to bother with like rebasing. I mean, I guess I'll just do like um I'll just manually calculate the gadget offsets in every case. Which is going to be a huge pain. But I was gonna use this gadget here, which I already pasted over. So let's do. All right, so that's gadget one. I just want to type this a billion times. I'm gonna be real lazy here. It's been a while since I wrote a ROP chain in C. Come on. All right, so if we can point the program counter at this address, you know what? Screw all of this. And then we're gonna want to put this address at the base of the map. Well, actually, this is just gonna do something weird, isn't it? Um, I don't think that gadget is good enough. Oh, wait. Um, literally that one that I was just at. Dang. Do I have control over any other registers here? See, this is where I should be firing up a debugger, isn't it? Let's quickly go and do, oops. do all this stuff. Let's put this in here. So this will crash nicely. So we want to crash and take a look at registers. I can look at the registers when it crashes and see if any of them are interesting. Yeah, my batteries are dead. Shoot, I didn't charge them, did I? Well, that's good. That's nice. Hang on, I gotta put some batteries on a charger for my vape. Which is horribly inconvenient. My vape is now dead. So what I'm thinking is I need to get a stack pivot. It's actually fairly straightforward to exploit from here. So we want to get a stack pivot, then ROP to get probably shellcode. I mean, we could just ROP to directly elevate ourselves. But that seems way more complicated than just ROPing to get kernel code execution. So that's RSI points at my data as well. So that's really convenient. As does R14. So I can use RBX, RSI, or R14. So let's take a look at so that's ECX, which I don't have. I have RSI, RBX, and R14. And these are all going to be EAX. So many EAX. Oh. Wait, there's ECX. And then RET, weirdly. I think this subtracts that much from the so we want to try this gadget instead for the starting gadget. So that should be at the 0th index of the map, I think. So let's make the map. Where's my that's 64T. And then right, I'm not losing my mind, right? I don't have RCX. Why am I RSI? EDI ret F. I don't think. Well, this is going to be tricky. There's so many gadgets, it can be difficult to figure out exactly what you want to look for here. I mean, this could work. Right, because EAX is going to be. Yeah, that's going to be. Oh, well, I guess one of these, like, call something else could work. EAX would totally work. What am I doing? Okay, there's not an EAX ESP rep, but there is ESP EAX ret, right? There was a huge pile of them. Yeah, right here. Let's try like this guy. All right, now that stupidity has been cleared out of the brain, right? Because EAX is going to be right where we want it. I don't know why I thought that we couldn't use that register, you know, when I should totally be able to use that register. And then do map 0 equals stack pivot. I may have missed a dereference. Let's see what this does. So I haven't run this in a while. Maybe I screwed something up? Or maybe I need one. Maybe I need this. I don't know if that works. It appears to. Well, that's still wrong. So it's at. It's at. I'm trying to find the thunk racks. What the actual assembly for that is. This is where I should set up a debugger. Fine. I'll just do that. Why is this so complicated? Is this really this complicated? I don't think so. try. Is it literally just tech S? Is that how you're supposed to do this now? Oh, it really is that simple. Now what happens if I crash it? That doesn't do what I wanted. Well, I can, so I have KSLR disabled, so can I like break here? Maybe? Nope. Well, that was as useful as I expected that attempt to be. I have a GDB server, it's just don't know how to trap on uh when it kernel panics. I'm not sure why I'm kernel panicking and not doing something more interesting. Right, so I'm passing in. See, I think this Rax is like wrong. Because I should be at. So I don't think I don't think I need that ampersand. I think that is correct. Just to pass the map address directly. And then I look at gnote. Right, so it's already done this. Oh, times 8. Oh. Um Rax times 8. Right, so I need to do like I need to divide the address by 8 and then subtract probably 220 from it because that's the offset it's accessing at, probably. That seems really wrong. Well, let's just try dividing it by 8 and see what happens. Yeah, see, it's like code, bad rip value. But I don't know what that rip value that it's actually trying to load is. Right, that's the issue that I'm having. Um, Am I just doing this really stupid? I'm gonna take a few minutes break, um, and come back to it with fresh eyes because I think I'm doing this really dumb. I think I'm just overlooking something obvious. So I will be back in a moment. Okay, I'm back. So I think I know what I was doing that was stupid, or I think I know the obvious thing that I was missing. Um, Unfortunately, my window capture is still not like auto switching. Hang on, I need to fix that. It should be doing. Oh, because this one is bad. There we go. Now that should be fixed. Yep, okay. I forgot to update the um is it I can literally just out of bounds on this, can't I? Yeah, yeah. So what I want to do is do like, let's get the offsets right first. Um, so all of this is not necessary. Where would I do this? Let's do like, so that'll fail the check and populate note 2 with that size value. And then I can look at, so this is 6C0, be quad word, quad word, what does this struct look like? Size is the first long. This is going to be here, 6D0. And then minus 220. Well, wait, it's the BSS, so it's gonna be, I am not sure whether that gets linked weirdly. Um, balls. I'm getting tired. I might stop soon. I want to get program counter first though. I keep spacing out. Um, the question is, what's the offset from, right? What's the offset from this guy here to get to the the notes buffer, just like here. And I'm not 100% sure. I think I need KL sims, maybe. Right, because this is in the row data. Um, I could just like print the two. I mean, it'll be in proc modules, but I don't think I'm gonna get that info without um. Yeah, see, it's not gonna give you the address, but I can like just guess that maybe it'll be mounted. Or wait, hang on. I can do this with that debugger that I literally just had. Okay, so um, okay, so let's do that. No, what? Operand out of range. I'm sorry? Oh, okay. So then if I do debugger, oh, really? Okay. Jeff is probably screwing me over here. What do I want to do? I'm not 100% sure on how to determine this offset, right? Like, I know that that's what I want to do. I know it's in there somewhere. I mean, I could literally just brute force it. So I've got notes, and then I've got this. What's the difference between um I'm not sure how to do this one. Right? Like I could let's make it crash again. I'll admit I'm kind of slowing down. I may wrap up here soon. I really want to get program counter tonight, but I'm not 100% thinking properly. All right, so it's like kernel paging request at some weird freaking address. Is that like so if we change dead beef something else, right? Like if we do like, yeah, see that changed. I don't fully know what's going on. Uh, I wish I could get some value there that I would like be confident at knowing what the heck is going on. Um, oh, you know what? This isn't gonna work. Like the idea that I had isn't gonna work anyway because this is an int, so I can't get into high memory and SMEP is enabled. Snap isn't enabled. I could put a fake jump table in user space, which means I want to fill my user space with allocations. Um, but I'm not going to win the race every time. Or I'm not gonna win the fill every time because I can't fill like all of user memory because I have my stupid elf living in things. Um, and I'm not sure what value I want to give it. Well, so it's gonna be multiplied by 8. So let's do like, where is it? Like this value, right? So like this value, or what's the module address is like FC, I think. Yeah, this thing. 1, 2, 3, 4, 5, 6, 7. Yeah. This will be like some module address. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No wait. 1, 2, 1, 2, 3, 4, 5, 6. I need one more. Probably. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, that's fine. If I want to get down to user memory, then I need like, that's like, oh, that's close. Oh, wait. Is that truncating? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this will work. and then I'll multiply by 8. That'll get me down there, and then I don't. Can I map 1000 on that target? Let's find out. Cool. Oh. Right. So I think this offset. So the slide only goes up from there, right? And so I'll just need to spray. I don't know how many. I think it modifies. I don't know how much range there is on KSLR, but we can do some experiments to find that out. Hey, null. Okay, well that's different. That is a change. So this is like not what I want anymore. So that was never gonna work. If I do that, oh, and then let's just do that. Oh, still null. I think this should put like, oop. Hey, there we go. There's 4 ones in rip. So that's at some offset like into my page. I think it's at 220 into my page. So if I do like if I change this back to, or where's my gadget? I wrote it down somewhere. It's right here. We're at 134. Let's worry about that in a moment. Let's do let's do like that. Stack pivot undeclared? Oh. Making progress again. Uh, um, um, maybe I need to divide by 4? I mean, really what I want to do here is I just need to do like, oops. So I just want to do like, instead of this, and then this should tell us what the offset is. Is that, did I screw up? Why is that zeros? Am I like way off in terms of where my DREF actually is? Oh, yes, I'm slightly off. There it is. That two birds, one stone. Map it 2000. Remove this. Set it to 0 just to be safe. And then this is going to be this should stack pivot in theory. Although I'm still not dealing with KASLR, which I'll do next. Whoa, hello. That's interesting. Let's see, dump stack. It doesn't like my stack. RSP is very, very wrong. What did I do? EAX, ESP. That's not, oh, I need to map. I need to map wherever the heck EAX is actually pointing. I might have time to get to doing ASLR stuff tonight. Good. Rax. Rax is here, right? So that's 1, 2, 3, 4, 5, 6, 7, 8. Well, so we want to map that page now. Is that map? Let's find out. It might be. This doesn't need to be global anymore. Fix my music again. If you want to listen along, I'm now listening to Anchor Drops by Humphreys McGee, one of my favorite albums of all time. All right. So that change this table so it is what it is, right? And then that'll put that address, and then we need to map this page. And then memset stack. And what this should do now is put our stack on that, because that's mapped now. Oh, I didn't change this back, right? I mean, obviously my stack is screwed, so there's no reason. I mean, my stack is very clearly messed. Where's my stack pointer? Like, that's like way off in the weeds. I don't know what's going on with that. Um, why is my RIP in GPU driver load? I'm sorry? That seems wrong. Well, let's just like make this like super humongous. Yeah, I may not have enough memory for this, but I'm wrapping up soon, so I'd really like to get both of these. I mean, I don't know why my RISP. Am I? All right. I think I'm gonna call it a night there. Let's get this into a nice state here. Get rid of these. This should get me 4 ones in program counter, and then I'll be happy with my progress. Yep, there we go. Cool. All right, well, thank you everyone for watching. I'll be picking this back up again tomorrow around the same time. I'm gonna be streaming a lot this month, doing this challenge this week. I'm hoping to do like a challenge a week for the whole month, two nights a week. Tomorrow's Thursday. I may stream on Friday instead, probably. Um, the um, the plan is maybe Wednesday. What is today? Wednesday? Yeah, like Wednesday, Friday, Sunday. Wednesday, Friday, Sunday, long stream on Sunday maybe. Um, there's really not a great like every other day type of schedule that fits into a 7-day week. So, but I will be tweeting about it and letting people know on Discord, however you found it. And I'm gonna unlist the VOD, but it's if anybody wants the VOD, just reach out to me on Twitter. And maybe I'll just leave it. Maybe I'll just leave it. But yeah, so looking forward to finishing this one. Got made pretty good progress. We've got the info leak, we've got program counter control. Need to clean up, start doing some ROP stuff, and also do a KASLR defeat. If it didn't have SMEP, we would just win because we could just jump to our shellcode. So we're gonna need to. I'm gonna need to go through and you know figure out why this gadget isn't working properly. Probably just a typo somewhere, or something weird with the trace output because I'm screwing up the kernel stack. Um, but yeah, thank you for watching, everybody. I need to figure out how to tell YouTube that I don't want to be live anymore. There it is. All right, have a nice night. See you soon.